Well, good evening everybody. You're joining me for the second to last video that I'll be posting for the Embedded Co-Design module. Before you is the populated PCB. In one of the previous videos I showed you the blank PCB just after it had been created. Just to remind you, it's the back. It's quite neat and tidy, as you can see. Pretty good. So this is basically a testing video of the PCB. Some things that I want on the original schematic are as follows. There wasn't originally a switch, that's just that one there. It's running off a 9-volt battery, and I've also obviously added the header connector so I can program the board directly. I've also added this LED over here. That's actually just basically a heartbeat LED, albeit I purposely didn't connect it to any particular pin. It's just sitting there. The idea being, I set up an array of header pins over here, which are just grounds for testing purposes. So if I place the header cable on there and on there, and use the male to female header cable, we can test all of the pins. Now I've programmed this currently with a program just to select and pulsate all of the input and output pins. So hopefully every pin that I touch, excluding the grounds, will either flash if they're an input or an output, or be constant if they are just a supply voltage. So there we go, it's obviously a supply. They're all flashing away. So the header pin that I'm touching at the moment is for the LCD screen, which is obviously just over there. As you can see, we went for quite a large one to make the most of the user interface. Sadly, this is actually a character-based screen. That was the easiest alternative for the time being. Interestingly, for other projects I'm working on the side, you can see here I've got a graphics-based LCD screen. This has actually got a nice backlight as well, that I've only recently started playing with. So obviously you can have a lot more scope for design with that screen. So that'll be another interesting project to put up on Sparkypedia at some point. Alright, so over here we've got these 4 pins are for the SPI buffer. So there is the SS, the Musu, Mausu, and there we go, and the slave select. So if you can see that behind my hand. Over here, these 2 header pins are for the joysticks. The first one's a ground. And there's the 2 analogs for each of the axes, and there's a select button. There's also supply, which will be fixed, as you can see. And that one over there is exactly the same. Things that are missing from the board at the moment are the buzzer, which is going to be connected just over here. And if I touch the back, hopefully if I can find the... oh, where is she? Where's the hole gone? There he is. There we go, that's flashing away. And also at the top over there, there's a couple of holes. That's for the one of the buttons. It's going to connect and control the claw. So there we go, that's flashing, so that works perfectly. Here obviously we've got the joysticks we're going to be using. There's 2 of those. So this is pretty much the PIC side of the project built. Now we've just got to test the finalized code and running all these 3 together. As you can see, the LCD screen has got a bunch of header pins on the back there as well. So that'll work very well. Nice and tidy. Yeah, so the other side of the project, the DEO side, obviously has a robot arm. And this will be sending, well, this will be doing as it's told because it's in slave mode, but effectively all the user interactions will be going through the PIC and being sent over to the DEO. And one of our other colleagues used the university's 3D printer. That was an interesting experiment. So far he's only made the lid, but it looks really good, so we should have a nice handheld case when this is finished. Have quite a nice completed product. So thank you for watching, and once I put this all together I will try and pop up another video. You never know, there might be 2 more videos, depends how we go. So thanks for watching, and see you again. Bye bye.